Hey guys, so today you guys are looking at 3.4's homework asking about solving systems of linear inequalities. And we started off on number 1 and went straight through to number 4. And we're doing guided practice today. Guided practice, guys, tells you how to work out the problem on paper in your textbook. So, yeah. So you don't actually need this video if you just want to know the answers. Though if you just want to know if you want to know how to work the problem out and you can't understand the textbook because it's written in ancient Egyptian hieroglyphics, then join the club and watch the video, will ya? So there is your system. Now here's the main deal, guys. You need to be able to graph these. That's the whole point. If you like graphing one of these was what we learned how to do in chapter 2, right? Math builds on itself. You can't you can't not get something. Like you have to try to get it because it's going to be used over and over and over. And if you just get it the first time or the second time or the third time, but on that first attempt, right? On that first concept, you're going to use it on all these other concepts. So this is already in slope-intercept form. You got a y, and then it's sine, like equal to or not, and then something x plus something. This is slope-intercept form. So what that means is that this is the y-intercept, that's the slope. So you start with that number here on the y-axis, right? That's what it means to be the y-intercept. So you go up to 5. 1, 2, 3, 4, 5. So we start at 5. Then from there, you do up 1, right 3. Up 1, right 1, 2, 3. Okay. And then it's going to be a solid line. And I'm going to do that in a different color. And it's solid because it's equal to, right? It's equal to. If it's equal to, it's solid. Now, the next line, based on that idea, if you don't know how to graph, if you did not graph this next line, you need, or this next line, you need to do so. Okay, pause the video or go backwards and see, okay, how did I get this? How did I do? What did I do? Then try to mimic, do the same thing. Math's all about like mimicking. All right, well, let's do it. So you start here at this number, that's -2, and that's on the y-axis. So we get down to 2. And then you go up 5, right 4. Up 1, 2, 3, 4, 5, right 1, 2, 3, 4. And then you draw a line. And this time it's going to just be like a dashed line. And then you shade. So here's how you decide how to shade. The first things first, start testing points. Test 0, 0, because if your line doesn't go through 0, 0, it's going to be the best point to test. So you plug in 0 for x and 0 for y into this problem and see if it's a true statement. So is 0 less than or equal to 0 plus 5? So 5. Is 0 less than or equal to 5? The answer to that question is yes. So it works. Then test 0, 0 on this one. Is 0 greater than -2? Because you plug in 0, plug in 0. That'll cancel out, giving you just -2. Is 0 greater than -2? That's also a true statement. So we tested this point from this line, and it gave us a true statement. That means you need to start at the line and shade towards that true statement. So we're shading over here. I have a tool for this. Right? So then, since it's true on the other statement as well, so if you look, this line here, it's true for this one too, so you shade towards it again. So then you would shade over here. Let's make this a lot bigger, shall we? Now, the commonly shaded region, that is your actual solution. So the commonly shaded region, that means the region that is like the overlap, okay? The overlap happens to be this area here. This is the overlap. So this is the solution region. Okay? So that's the solution region. Man, I really need to get into art. I think I like it. And this thing is so good for it. It's so and it's so expensive. This tablet I'm writing on, guys, was like $900. No lie. It's super duper high quality. Anyway, whatever. So there's your solution. It's the two lines with the proper shading. Now, moving on to number 2. I'm going to try to go a little faster. You've got 4x plus y is greater than 8, and then you've got 3x minus 5y is less than or equal to 15. First things first, get them into slope-intercept form. This is another thing from chapter 2. Actually, chapter 1. So you want to get it into slope-intercept form. So you're going to subtract 4x, and you're going to get y is greater than negative 4x plus 8. That one's good. That one's in slope-intercept. Now you want to subtract 3x. Remember, you're moving the x to the other side and then getting rid of any coefficient in front of the y. So your negative 5y is less than or equal to negative 3x plus 15. 906. Oh my gosh, I need to hurry this up. Then divide by negative 5, divide by negative 5, divide by negative 5. When you divide by a negative, it flips this sign. So you're going to get y is greater than or equal to, not less than or equal to, 3/5 x minus 3. The 3 and the 5 make 3/5. The negative and the negative make 2 positives. Then 15 over 5 is 3, and that's negative. There's one negative, so it becomes negative. So here, you graph both of these and shade. So starting at 8, 1, 2, 3, 4, 5, 6, 7, 8. Start at 8, go down 4, right 1. Down 1, 2, 3, 4, right 1. And your line is going to be dotted. Then down, start at negative 3. Go up 3, right 5. And your line's going to be solid. And then decide how to shade. Is 0 greater than 8? Is 0 greater than or equal to negative 3? No and yes. So that means we tested this point. On the dotted line, it was a no, so we shade away. And then on the solid line, it was a yes, so we shade toward. So if you're shading all of this region and then all of this region, the commonly shaded region will be here. So there's your commonly shaded region. It would just be this area here that I'm shading, and now in green. Okay, moving on, number 3. Number 3, 7x plus 2y is less than or equal to 14, and then 3x minus 9y is greater than or equal to 18. Get them into slope-intercept form. Subtract 7x, subtract 7x. 2y is less than or equal to negative 7x plus 14. Divide by 2, divide by 2, divide by 2. Y is less than or equal to negative 7 over 2, x plus 7. Now, minus 3x, negative 9y is greater than or equal to negative 3x plus 18. Divide by negative 9, divide by negative 9, divide by negative 9. Being a teacher really helps you narrate things. You're going to get y, you're going to flip the sign because you're dividing by a negative. Anytime you multiply or divide by a negative, you flip the sign. So this, a negative over a negative, a negative over a negative makes a positive. I wonder how YouTube's going to try to subtitle that. Huh? Take that, YouTube. Okay. 3 over 9 reduces into 1 over 3. X and then minus 2. So, graph this. You know, I was about to get off topic. No, it's not happening. All right. Start at 7, go down 7, right 2, and it is a solid line. Start at -2, go up 1, right 3, and it's a solid line. Figure out how to shade. Is 0 less than or equal to 7? Yes, that's a true statement. Is 0 less than or equal to -2? No, that's a false statement. So, for this line, let's get this straight. For this line, this one going up and down, this was a true statement. So you shade towards. Then for this line, it was a false statement. So you shade this way. So you're shading this way and this way. And so this cross section is the commonly shaded region. So this is the commonly shaded region right here. All right, last problem. Number 4. Y is greater than or equal to 2x minus 3. 2x plus y is greater than -8. Y is greater than -3. So this is already in a good form for us. This one needs to be put in slope-intercept form. So subtract 2x, and you get y is greater than -2x minus 8. Now all of our things are in a good shape for us. Good form for us to graph. So here we're going to go all out and give ourselves a nice big graph. So graph all 3 of these. You graph this one. Whoops. You graph this one. Hey now. I said digital airbrush. Graph this one. Graph this one. And graph this one. All right, so first things first. Start at -3, go up 2, right 1. Start at -3. Those are too close together. All right, that'll work. So start at -3, go up 2, right 1. Start at -3, go up 2, right 1. Up 2, right 1. And then it's a solid line. Then here, start at -8, go down 2, right 1. Start at -8. Here's a trick. Say you don't want to go down anymore because it's like off your graph. If you go the reverse direction on both, it will work. So we were going to go down 2 and right 1. If you go up 2 and left 1, it'll still be on the same line. And then it's a dashed line since it's not equal to. And then on this one, y equals -3. That's a horizontal line through the y values of -3. So there's -3. And it's a dotted line, dashed line. And now you need to figure out how to shade. So here, is 0 greater than or equal to -3? Yes. So we shade towards, so we shade this way. Then, is 0 greater than -8? That's also a correct statement. So then we shade towards 0, 0 from the yellow line. Then, so far this would be a commonly shaded region. Now for our next trick, y's are greater than -3. So is 0 greater than -3? Is 0 greater than -3? That's a yes. 0 is bigger than a negative number. So you shade up. So we tested 0, 0, you shade up. So our commonly shaded region is this one right here. And it's sectioned off like this. And then all this in the middle here. All right, that'll be it. That's all we have for today. Wow, I like this. Awesome. That's me. All right. Wow, cool beans. So there's your homework. I'm just gonna doodle off into the sunset, and And then yeah, that'll be it. And I'm just gonna keep drawing here. You can just go ahead and stop the video. Man, everything looks so artistic whenever you're drawing with this pen. It makes even crappy handwriting look cool. It's like this looks like some cover of an album. Yeah, awesome. You need some sweet. What do we need? What do we need? We need some sweet. Yeah, you can just go ahead and quit the video. There's no need for you to watch this. I'm just I'm just doodling here. You just pause the video. You just go ahead and quit. I'm not done yet. Let's see here. What else do we got? I think this dry media is pretty cool. What other tools are there? Wow, look at all these tools. Sharpen, dodge. Whoa, dodge. If you can dodge a wrench, you can dodge a ball. Let's see here. Just add water. What does this do? Oh, it smears things. I don't like that. What else do we got here? Fine spray airbrush. Whoa. That's kind of neat. I kind of like that. See what color would go good. Got to apply just the right pressure here. Just the right pressure. I think there's a little too much going on right there, but it's whatever. Actually, I might be able to touch it up. Man. No, just gonna have to leave it. It's hard to mimic the. Oh, that's pretty neat though. I like how grainy it looks. Cool. I can dig it. What else? Kind of watercolor. Kind of watercolor. It's not doing anything. Hey, what are you doing? Doing something. Oh no. No, stop it. Kind of watercolor. Digital airbrush. A star. Grass. Grass. Oh, grass. Grass does not belong in this picture. Yeah, grass doesn't belong in this picture. What are you doing, grass? Get out of here. Dark hatch brush. What in the world? That looks crazy. Wow, it's really sensitive to pressure. I'm not changing the brush size, I'm just increasing the pressure. That looks pretty cool. Kind of like a calligraphy pen. Wow, if you interesting. Well, that'll be it. 20 minutes and 50 seconds. I got myself a pretty sweet finished design here. Just gonna add this to my first math rap album cover, where I rap out all the great math formulas that exist in the world, and this will be on it. Well, that was probably a waste of. Was that like. That was a long time I was sitting there drawing. Yeah, whatever. Hopefully, you are not watching this, and you stopped a long time ago, and you didn't waste your life watching this.